Karnaugh maths, a visual way to simplify logic expressions. It gives the most simplified form of the expression. Here you can see the rules. A K-map is a graphical method used to obtain the most simplified form of an expression. The simplest form of an expression is one that has the minimum number of terms. By simplifying expression to one that uses the minimum number of terms, we ensure that the function will be implemented with minimum number of gates. By simplifying an expression to the one that uses the least number of literals for each terms, we ensure that the function will be implemented with gates that have the minimum number of inputs. Here the gates are nothing but logical gates. For example, AND gate, OR gate, NOT gate. Yeah, these. There are types of K-maps. Here you can see a three variable K-map. First of all, here you can see in the first slide, we are seeing a three variable K-map. When it comes to vertically, it is represented with A, and when it comes to horizontally, it is represented with B and C. You can see here the vertically the first column is represented with O and the second column is represented with 1. You can call it O or 0, which is likely. And here B and C, sorry, and here B and C you can see 0 0 0 1 1 1 1 0. Here 0 comma 4. In this K map, if it is represented simply, that is A, which is not having any overline above it, then it is equal to 0. If it is having an overline, then it represents it 1. Here you can see in the first one 0 comma 4. When we add 0 comma 4, here first first column is equal to the given value. So that's the reason why it is filled with ones, and you see it is highlighted. At the same way it is for 4 comma 5 and 0 comma 1 comma 4 comma 5, 0 comma 1 comma 2 comma 3. In this, will be only highlighted if they are adjacent to each other. Even though if they are not adjacent to each other, but it is replaced with 1, will not consider it. And here you can see again 0 comma 4, which is A bar comma C, 4 comma 6, 0 comma 2, 2 comma 4 comma 6. And three variable K-map examples. Here in this K-map, it is only considering ones. It is okay if we represent the empty squares with 0, or we can leave it empty. This is a 4 variable K-map. The same way in this 4 variable K-map, we require 4 variables: vertically A, B, horizontally C and D. And this is how it represents actually. The advantages of K-map. The K-map simplification technique is simpler and lesser error prone compared to the method of solving logical expressions using Boolean laws. It says that K-map is a very easy and advanced way where we'll be getting very minute errors or zero errors. It prevents the need to remember each and every Boolean algebraic theorem. It involves fewer steps than the algebraic minimization technique to arrive at the simplified expression. K-map's simplification technique always results in minimum expression if carried out properly. And let me come to the next slide. These are the disadvantages. As the number of logical expression increases, the K-map simplification goes on increasing. That's the major drawback in K-map. You can see an example of figure 1 about K-maps. And final conclusion is, having analyzed the structure of K-maps, we'll be doing only for a specific amount of discrete amount of data. If the data is large, then it is not suggested as not preferable going to K-map. Why? Because as I have said before, for large expressions, it becomes more complex to solve the expressions. And this is my seminar topic, and thank you.